Most organizations believe they have AI agents right now. They don't. What they have are chatbots trapped in tabs, ephemeral, context-starved, and useless the moment you close the window or switch devices. You ask your AI a question. It answers. You close Slack. The agent forgets you exist. The thing is, everyone blames the model. We tell ourselves we need a smarter LLM or better prompting. But here's what's actually broken. The architecture, not the brain, the nervous system. This episode is about the shift from chat to fabric. We are moving from isolated conversations happening nowhere to a persistent, multi-device system that actually behaves like a workforce participant. And I'm going to show you why the GitHub Copilot SDK and Microsoft Agent 365 are blueprints for how this needs to work. The expectation versus reality. Let's start with what we're promised. You have an AI agent. It's intelligent. It knows your context, your projects, your priorities, and your past decisions. It remembers your preferences. It works across every device you touch. You start a task on your laptop, and then you pick it back up on your phone without missing a beat before finishing it on your tablet. The agent moves with you. This agent doesn't just answer questions. It owns work. It coordinates with other agents. It knows which data it can access and which it can't. When something goes wrong, there's a full audit trail showing exactly what it did and why. That's the dream. Now, the reality. Current agents reset every session. They lose context the moment you switch applications. They operate in complete isolation from every other agent in your organization. A customer service agent can't talk to a finance agent, and a sales agent can't pull inventory data, which means they're trapped in their own silos while running the exact same reasoning from scratch. When you give a single siloed agent a multi-step task, it fails 65% of the time. The moment complexity enters, the moment you need it to remember a prior decision, adapt based on new information, or coordinate with another system, it falls apart. And here's the deeper problem. We've been treating agents like chat interfaces instead of like what they actually need to be, workforce participants. Chat is stateless by design. Every turn is independent. You ask, it responds. Done. But agents don't work that way. Agents require state. They need memory across sessions. They need decisions that compound. They need context that persists across days, across devices, and across teams. The vendors have sold us chat because it's easy to understand. It maps to Slack. It maps to Teams. It's familiar, but it's the wrong abstraction entirely. So organizations invest millions in copilots and AI agents that can't scale beyond toy scenarios. They can't coordinate, they can't remember, they can't persist. And when you try to ask them to do something genuinely complex, something that requires context from multiple systems, multiple time periods, and multiple people, they collapse. This is why a typical enterprise ends up with a graveyard of failed AI projects. Not because the models aren't smart enough, because nobody built the infrastructure for agents to actually be agents. That's what we're here to fix. Over the next hour, we're going to walk through the architecture that actually works. We'll diagnose every structural flaw in how agents are built today. And we'll show you the blueprint, the real blueprint, for what a persistent, multi-device governed agent system looks like. It starts with understanding that this isn't about chat at all. The silo problem defined. Let's get concrete about where your agents actually live right now. Your Salesforce deployment has a CRM agent. It understands deals. It knows your sales pipeline. It can answer questions about pipeline health, forecast accuracy, and deal progression. But it only knows about Salesforce. It has no idea what's happening in your customer service system or your finance platform. Meanwhile, your Jira environment has its own agent. It understands tickets. It knows sprint velocity. It can analyze engineering capacity and predict release dates. But ask it a question that requires data from your incident management tool, and it goes silent. It doesn't have access. It doesn't have context. It exists in isolation. Your CRM has a different agent. Your accounting platform has another. Your help desk has one more. Every major system you use has built its own AI capability, and every single one operates in complete isolation from every other. Here's the architecture underneath. Each silo maintains its own context window, its own memory store, its own permissions model, its own data schema. An agent in Salesforce uses Salesforce's APIs to fetch data. It authenticates with Salesforce credentials. It operates inside Salesforce's security boundary. It has no bridge to any other system. The result is exactly what you'd expect. An agent in one system cannot see an agent in another. They cannot coordinate. They cannot pass work between them. They don't know each other exist. Now, let's think about what this means operationally. A customer calls with a billing dispute. Your customer service agent in the help desk system tries to resolve it, but the resolution requires a credit adjustment. That's a finance operation, so the agent escalates to a human. The human logs into the accounting system, manually reviews the account, manually processes the credit, manually documents the decision, then logs back into the help desk to close the ticket. That manual handoff, that's a human becoming an integration layer. You're paying salary to bridge a gap that automation should have handled. Or consider a sales scenario. A sales agent in your CRM identifies a high-value opportunity. It wants to route that opportunity to the right team member based on territory and capacity. But capacity data lives in your HR system. Territory rules live in your legacy ERP. Availability calendars live in Office 365, so the agent can't actually route anything. It generates a recommendation. A human reads it, manually checks capacity, manually verifies territory, manually sends an assignment. This happens thousands of times across your organization. Not because the AI models aren't smart, because the architecture prevents them from being smart. The deeper architectural truth here is worth stating directly. Siloed agents are not agents at all. An agent is something that observes a situation, makes a decision, and takes action in service of a goal. But if your agent can only observe within Salesforce, can only read data in Salesforce format, can only act through Salesforce APIs, and has no way to hand off work to another system, it's not really an agent. It's sophisticated autocomplete. It's a chatbot that has memorized your database schema. This distinction matters because it shapes everything that comes next. It's why your current agents fail at complexity. It's why you end up with dozens of isolated bots instead of a coordinated system. It's why you're still hiring humans to do the integration work that machines should handle. The fix isn't to make each individual silo smarter. It's to break the silos apart and rebuild them as a connected fabric. Why chat is the wrong model. The conversation metaphor is poisoning how we think about agents. When you call something a copilot or an assistant, you trigger an assumption in the listener's brain. They think about Siri. They think about talking to someone who helps you do your job. It's intimate, it's responsive, it's conversational, and that mental model shapes everything that comes next, including the technical decisions that people make. But here's what's actually happened. The vendors have stuck an incredibly powerful AI capability into a chat interface because that interface was the easiest thing to build and the easiest thing for users to understand. And then the entire industry internalized that constraint as a requirement. The reality is different. What you need from an agent is not conversation. Conversation is ephemeral. It's momentary. You have an exchange, you move on, it evaporates. And that's fine for a help desk experience. You have a question, the chatbot answers, you leave. That interaction is self-contained. But agents in an enterprise context can't work that way. The moment you try to use them for actual work, for orchestration, for decision-making, for coordination, the stateless conversation model falls apart. Think about what stateless actually means operationally. It means the agent has no memory of prior context. It means every decision it makes exists in isolation from every other decision. It means when the conversation ends, everything the agent learned about your situation disappears. There's no continuity, there's no learning, there's no compounding of judgment. Now overlay on top of that the fact that an agent in a real organization needs to do things. It needs permissions. It needs to know which databases it can read from, which APIs it's authorized to call, which files it can modify, which users it can act on behalf of. An agent needs an identity. This is where the chat model breaks down completely. In a conversation, you don't have an identity. You're just a user. You have a name. Maybe you have a role, but you're ephemeral too. You come, you ask your question, you leave. The conversation doesn't outlive your presence, but an agent that's coordinating work across systems can't be ephemeral. It needs a persistent identity. It needs to be auditable. When an agent makes a decision that affects a business process, you need to be able to trace that decision back to the agent, verify that the agent had the right permissions, and audit exactly what happened and why. Vendors have built audit trails on top of chat systems as an afterthought. They log the conversations, they store the prompts. But the entire architecture underneath treats the conversation as the unit of work, not the agent. The consequence is that agents built on conversational architectures can't scale beyond toy scenarios. You can build a chatbot that answers questions about your product knowledge base. That's within the constraints of the chat model. You can even build one that uses tools, that reads some data, runs some analysis, returns a result. Still works. But the moment you need an agent that remembers decisions across multiple conversations, operates with its own distinct identity and permissions, coordinates with other agents, maintains audit trails that satisfy compliance requirements, executes long-running workflows that span days or weeks, the chat model doesn't just fail. It becomes an active obstacle. You're building increasingly elaborate workarounds on top of a foundation that was never meant to support this kind of work. What an agent actually needs to be is a system participant, not a conversational interface, a participant in your business processes. Something with identity, something with persistent memory, something that can be governed, something that operates continuously, not just when a user is typing at it. This is the fundamental mismatch. And until organizations understand that their agents need to be system participants, not chat interfaces, they'll keep building agents that look impressive in demos and fail in production. Session persistence, the missing piece. Your agents are forgetting. The problem is simple. Most agents today are built on conversational architectures that are stateless. They don't remember context between interactions. They can't keep work alive across different times or different devices. The fix starts with a concept that most platforms ignore: the session. A session is the container where state lives. It holds everything an agent knows about a specific piece of work. It stores your current task, your past decisions, the data you've retrieved, and the files you've already scanned. Without a session, the agent has nothing to hold on to. Every time you talk to it, you are starting from zero. Think about how you use Slack. You close the app, you open it the next day, and your history is still there. You can scroll back and see the discussion. But if you ask a question that needs context from yesterday, you have to paste that information back in. The AI doesn't actually know it exists. That isn't a feature, it's a structural flaw. A session makes state durable by writing context to a database or a disk instead of just holding it in active memory. This means the information survives when the conversation ends. When you come back an hour later or a week later on a totally different device, the agent retrieves that context. It continues exactly where it left off. GitHub's Copilot SDK treats session persistence as a core architectural feature. It isn't an afterthought or something you bolt onto a chat system. The session management is baked directly into the runtime. When you start an agent session, you get a stable session ID. You can save that ID, pass it to another device, or close the application entirely. Hours later, you can create a new connection using that same ID. The entire state comes back. Every decision and every piece of memory is restored instantly. The mechanism is straightforward. The SDK keeps persistent event logs that survive even if a process dies. When the session resumes, the agent doesn't recreate its state from scratch. It simply replays the log. It rebuilds its understanding of what happened and what data it accessed. This sounds simple because it is, but it's also fundamental. Imagine a developer starting a multi-day code migration. On day one, she uses the agent in her IDE to analyze the code and draft an approach. The agent keeps detailed notes on the risks and decisions. At the end of the day, that session is saved. On day two, she's away from her desk. She opens a web client on her phone and enters the same session ID. The agent returns with full context. It knows where the analysis stopped. It knows the architecture decisions. It continues the planning without repeating a single step. On day three, she's back at her desktop. It's the same session and the same context. The agent has been working on this for 3 days. It has accumulated knowledge that compounds with every single interaction. That is what persistence enables. There is a governance angle here too. Persistent sessions are auditable because every action is logged. Every decision leaves a trace. When an agent finishes a task, you have a complete record of how it got there. You see the tools it used and the data it examined. This is critical for compliance and for debugging when things break. The challenge is that persistence requires infrastructure. You need a place to store state and a way to sync it across devices. You need recovery mechanisms and audit logging. You need policies for how long you keep that data. This is why most agents are still stateless. It isn't because stateless is better. It's because building the infrastructure for persistence is harder than building a temporary chatbot. This is where the divide happens. Organizations that invest in this infrastructure gain a massive advantage. The ones that don't will keep building workarounds on top of architectures that were never meant to last. Multi-device as a structural requirement. The world where you worked from one machine is over. Your team doesn't stay on one device. Nobody does. You use a laptop in the office, a phone while commuting, and a tablet in meetings. You jump back to a desktop when you need a real keyboard. Your agent needs to follow you through every one of those moves. But here's where the current architecture breaks. A Copilot in VS Code disappears the moment you close the editor. You can't get to it from your phone. You can't find it in Teams. It only exists inside that one app on that one device. The knowledge the agent gained while looking at your code becomes useless the second you walk away from your desk. Every silo works this way. An agent in Salesforce can't be reached from a mobile app. An agent in Jira won't follow you to a chat. Each one is tethered to its own application. You have to manage separate relationships and separate contexts for all of them. This isn't a limit of the AI, it's a choice. The agent and the interface are fused together. If you separate the interface, you lose the agent. True multi-device architecture is different. It means the agent is not bound to a single screen. The intelligence and the memory live somewhere else. They live in a central place that you can access from anywhere. You use a thin client on each device. This is a lightweight interface that connects to the central agent runtime. The client on your laptop looks different than the one on your phone because they have different jobs. The desktop shows code side by side with analysis, while the mobile app shows a summary. But they are both talking to the same agent. They share the same persistent memory. The GitHub Copilot SDK shows us this pattern. The brain lives in the backend. It's a stateless runtime that scales and stays independent of the interface. On the front end, you have clients like VS Code, the CLI, or web interfaces. Every client connects to that same backend. Every client uses the same session. The benefit is context continuity. You start a problem on your laptop, the agent runs diagnostics and finds patterns. You save it, you move to your phone and use the same session. The agent resumes with everything it already discovered. There is no loss of context. There is no repeating work. You never have to remind the agent what you were talking about. It just knows, but this multi-device setup creates a security requirement. When state moves across devices, it travels over a network. It has to be stored, so multiple clients can reach it. It has to stay uncorrupted and protected from the wrong people. This is why you need a control plane. You need a system that sits above the agents and the devices. It enforces policies on who can access data and how state gets synced. It manages what happens if a connection fails. Microsoft Agent 365 is trying to be this control plane. It isn't just a tool for managing agents, it's a way to govern how they work across your entire infrastructure. The challenge is that this requires a total rethink of how agents relate to your systems. Most organizations haven't started that rethink yet. The GitHub Copilot SDK as the blueprint. The GitHub Copilot SDK came out in June 2026. It isn't just another tool for developers. It's a structural pattern. It's a statement about how agents should actually be built. And right now, it's the model that every major enterprise platform is moving toward. But here's the problem GitHub had to solve. They needed one agent to work everywhere. It had to work in VS Code. It had to work on the website. It had to work in the command line and in custom apps. Every one of those environments is different. They have different buttons, different user habits, different ways of showing information. If you tried to build a separate agent for every platform, you'd fail. You would end up with 7 different versions of the same brain. They would all start to drift apart. One would have a bug the others didn't. One would be smarter than the rest. It would be a mess. The solution was radical in its simplicity. You separate the intelligence from the interface. The core agentic harness is the part that actually thinks. It makes the decisions. It breaks big problems into small steps. And that brain lives in exactly one place. It's built once. It doesn't care what language you use. The runtime is portable. Whether you run it on Node.js, Python, or Go, you get the exact same behavior. You get the same reasoning and the same results every single time. Then, on every platform, you just have a thin client. The VS Code extension doesn't actually have any agent logic inside it. It doesn't manage context or make decisions. It's just a window. It opens a connection to the backend. It sends a prompt. It gets an answer. Then it shows that answer in a way that makes sense for a code editor. The CLI is the same way. It isn't reinventing the agent. It's just a different way of talking to the same brain. It uses text instead of graphics. But the intelligence behind the screen is identical. This matters more than it sounds. It means you don't have version drift. You don't have an agent in your editor acting differently than the one in your browser. You have one agent and multiple ways to talk to it. One source of truth. Session management is baked right into the SDK. It isn't something you have to bolt on later. The SDK handles session IDs and state recovery as a core feature. When you start a chat, it's persistent by default. You don't have to turn it on. You don't have to configure it. It just works. Tool calling is standardized too. Every agent uses the same pattern to talk to outside systems. You aren't reinventing the wheel for every new use case. You define your tools once, like APIs or scripts, and then any client can use them. The interface is clean. The implementation is standard. You get total consistency. What GitHub discovered is that you can build a universal agent. Not an agent that does everything, but an agent that can go anywhere. The same code and the same logic can be deployed to any device or app. This is the blueprint. This is what organizations should be studying. Because in reality, this is what an enterprise platform is supposed to look like. You shouldn't have 100 separate agents stuck in 100 different apps. You need one coordinated fabric. Word gets an interface, Excel gets an interface, Teams and Outlook get interfaces. But they are all talking to the same underlying intelligence. This is what Microsoft is doing right now. They are pulling Copilot Studio and Azure AI Foundry together around the same harness. It's why they're moving toward Agent 365 as a control plane. They are applying the lesson GitHub learned. Build the brain once, standardize how it connects, let different apps show it in different ways. The result is profound. If you understand this pattern, you can build infrastructure that actually scales. If you don't, if you try to glue a new agent into every single app, you'll end up with a fragmented nightmare. The SDK proves you can have both consistency and flexibility. You get a single brain, but you can put it anywhere. That's the blueprint. That's where we're going. Identity as the foundation. Building the blueprint is a start, but making it work in a real company requires something deeper. It requires identity. An agent without an identity is a ghost. You can't audit it, you can't control it, you can't govern it. When something breaks, you have no way to see which agent did it. When things change, you have no way to take away its permissions. It exists in your system, but it's invisible to your security. Most organizations are making this mistake right now. They use shared service accounts. They have one agent in Salesforce and another in Jira, but they both log in as the same generic integration user. From a security standpoint, this is a structural flaw. From a governance standpoint, it's a disaster. Here's why. When an agent uses a generic account, you lose the ability to see who did what. A file gets changed, a process starts, an email goes out. But your logs don't show that agent A did it. They just show that the integration account did it. That could be agent A, it could be agent B, it could even be a human admin. You have no way to know. Now imagine this with thousands of agents. Your audit trails become completely useless. You can't find out which agent caused a security breach. You can't set rules for one specific agent. You can't even turn off one bad agent without breaking every other system using that same account. The answer is to treat agents like people, give every single one its own identity. In Microsoft's world, that's an Entra Agent ID. It's a first-class identity in your directory. It isn't a service account. It isn't a shared password. It's an identity that belongs to that specific agent and nobody else. This changes everything. Once an agent has an identity, you can use every security tool you already own. You can use conditional access. You can use role-based permissions. You can use data loss prevention and sensitivity labels. Everything you use for humans suddenly works for agents. You can say, this agent can read the finance database, but only during work hours and only for certain records. You can enforce that at the identity layer. You can say, this agent can send emails, but only to people inside the company and only if a human says okay. You can set that as a rule. If an agent starts acting up, you can kill its access instantly without touching anything else. Identity is also what makes auditing possible. When an agent has its own ID, every action it takes gets logged under its own name. You can see exactly what it did. You can trace a chain of events back to one specific source. You can prove you're compliant because you have the receipts. From an operational view, this means agents have a life cycle. You provision them when they start. You manage their access as they grow. You delete them when they're done. You can change their credentials without hurting other agents. Each one is its own entity. Agent 365 treats identity as a core object. It isn't an afterthought. It isn't something you do if you have extra time. It's a first-class citizen in your directory, sitting right next to your human users. The problem is that most companies haven't changed their mental model yet. They still think of agents as tools, not as participants. They don't realize that an agent needs the same foundation as a person. That shift in thinking is just starting to happen. But the companies that get there first are going to have a massive lead in security and control. Identity is the foundation. Everything else is just built on top of it. The orchestration problem. Now we have an agent with an identity. It stays with you across devices. It has a state that survives every restart. But we've hit a hard limit that most people ignore. And that limit is scope. A single agent cannot solve a complex business process from start to finish. It doesn't matter how intelligent the model is. Think about what happens when a customer files a support ticket. Resolving that one ticket requires several specialized skills. You need someone to validate the issue and make sure it's legitimate. You need someone to dig through the knowledge base for a fix. You need someone to check the warehouse inventory for a replacement. You might even need finance to approve a refund. And then someone has to wrap it all up and talk to the customer. That is 5 different domains of expertise. It involves 5 different systems and 5 different data sources. Technically, you could give one agent access to every system and dump all that data into its context window. But in reality, that is a recipe for failure. The agent gets confused. The context becomes too heavy. The decision-making turns incoherent. It's like asking one person to be your accountant, your lead engineer, your lawyer, and your surgeon all at the same time. The answer is specialization. You build a support agent that only understands tickets. You build a knowledge agent that only searches documentation. You set up an inventory agent to check stock and a finance agent to evaluate refunds. Each one is laser focused on its own domain. Each one is optimized for the specific type of reasoning it needs to do. But now you've created a new problem. If you have 5 specialized agents, how do they actually work together? How does the support agent hand off the task to inventory? How does the inventory agent pass its findings over to finance? How does finance know if they should even approve the request? The answer isn't more chat. You can't just hope these agents figure out how to talk to each other organically. What you need is explicit orchestration. Orchestration means one agent takes responsibility for the entire process. It breaks the work into steps and assigns those steps to the specialists. This coordinator agent understands the overall workflow. It knows the exact sequence of decisions that needs to happen. It takes that customer request and splits it into subtasks. Validate the issue, search for solutions, check the stock, and evaluate the refund. Then it hands off to each specialist in order, passing along only the context that specialist needs and collecting the results. The pattern looks like this. The coordinator agent receives the ticket. It tells the support agent to analyze the issue. The support agent responds with an analysis. The coordinator then passes that analysis to the knowledge agent and asks for a solution. The knowledge agent returns a fix. The coordinator looks at that fix and realizes it needs inventory data. It asks the inventory agent if a replacement is available. The inventory agent returns the stock status. Now the coordinator has enough info to move to the final step. It asks the finance agent if a refund fits the policy, and the finance agent makes the call. At every step, the context flows forward. The support analysis informs the search. The search informs the inventory check. The inventory status informs the finance decision. The decisions compound. The reasoning stays coherent. And most importantly, there's a clear chain of accountability. The coordinator owns the workflow. Each specialist owns its specific decision. This sounds straightforward because it is. But it requires something most agent architectures don't support yet. You need explicit handoff rules. You need clear ownership boundaries. You need shared memory that stays intact as the task moves from one agent to the next. You have to define exactly when the coordinator should hand off to a specialist. You have to decide what information passes between them. You have to plan for what happens if a specialist fails or returns something weird. You even have to figure out how to handle 2 agents disagreeing on the path forward. This is where organizations typically fail. They deploy a bunch of agents without any orchestration layer. Each agent just operates on its own. There is no coordinator. There is no handoff mechanism. There is no way for them to actually collaborate. So you end up with a flat network of agents, and the humans still have to do all the integration work. The real architecture requires treating orchestration as a first-class concern. It isn't something you add later. It's something you design for from the very beginning. Memory as a governance asset. This is where persistent agent architecture becomes genuinely dangerous. When agents only exist for a single conversation, the damage they can do is limited. The chat ends, the context disappears. Even if something goes wrong, the mess is localized to that one exchange. But persistent agents carry their memory forward. They collect information over days, weeks, and months. That accumulated memory becomes the foundation for every decision they make. And that is both the feature and the liability. The feature is obvious. An agent that remembers your past decisions can build on top of them. It doesn't repeat work. It doesn't ask you the same annoying question twice. It keeps the context alive over time. That is what makes persistence so valuable. That is what allows an agent to work on a 3-week project and actually understand the goal. But the liability is something most organizations haven't thought through. Memory can be poisoned. This is a direct attack vector. An attacker doesn't need to break into the agent's code. They just need to get malicious content into something the agent reads and stores as a memory. It could be a document with hidden instructions. It could be an email with a secret directive. It could even be a chat message that looks totally innocent but contains a prompt injection. The agent processes that content and writes it into its memory as a fact. It stores it as context. It treats it as guidance for the future. Then, weeks later, the agent retrieves that memory to help with a different decision. The poisoned instruction resurfaces. The agent follows it. It takes an action it shouldn't take. It ignores a safeguard it was supposed to respect. And by that point, the original poison is buried so deep in the memory store that you can't see it. The attack is invisible until the consequences show up. The second liability is leakage. Persistent memory gets shared. An agent pulls information from one system and saves it. Later, that agent hands off a task to another agent and passes along the context. Now, the sensitive data from that first system is flowing into the second agent's memory. Eventually, it flows to a third. At every handoff, the boundary of what is restricted gets a little blurrier. Data meant for one specific context quietly becomes available in another. This happens at scale without anyone even trying to do it. Nobody planned to leak customer data across 10 different systems. The architecture just naturally moves information around as agents share context. Once that data is sitting in the memories of 5 different agents, you have lost control of it. The third problem is retention. How long should an agent actually remember something? If it's forever, you have an unlimited privacy exposure and a massive storage liability. If it's only for a few days, you lose the benefit of persistence. You need explicit policies. You have to define what gets kept and for how long. But here is the challenge. Deleting isn't the same as forgetting. If information is baked into a vector embedding or a graph structure, deleting the raw text isn't enough. You would have to rebuild the entire memory structure to truly get rid of it. Most organizations simply don't have the tools for that. From a security perspective, this means agent memory must be treated like a database. It isn't just a chat history. It isn't a temporary workspace. It is a genuine data asset. It needs access controls. It needs audit logs. It needs validation gates and integrity checks. You need encryption, backups, and recovery procedures, just like any other critical system. From a compliance perspective, the rules are even sharper. GDPR and data privacy laws apply to agent memory, just like they apply to a SQL database. An agent cannot just hoard information forever. It needs a legitimate reason to remember a specific fact. The person whose data is being stored has rights. The right to see it, the right to fix it, and the right to delete it. Regulators are going to expect you to show them how you remove a person's data from an agent's mind. That becomes incredibly hard when that data is buried in a memory store that's being used to inform other models and other decisions. The reality is that most organizations have zero framework for memory governance. They have no rules on what agents should remember. They have no way to check if a memory is valid. They have no audit logs and no way to delete info when a customer asks. This is the gap that has to be closed. It isn't about technical wizardry. It's about building a deliberate governance framework that treats persistent memory as the liability it actually is. The cost curve, why always-on agents are expensive. Most people hear this number and think it's a typo. An always-on agent that thinks in the background costs between $200,000 and $600,000 every year just to run. That isn't the cost to build it. That is the cost to operate it. This isn't a bug in the software or a mistake in how vendors set their prices. It is a structural reality of how agentic architecture works. Most companies don't see this coming because they are still in the honeymoon phase, and the small pilots they're running keep the real costs hidden. But here is why the bill gets so high. When an agent is always on, it is never actually idle. It is constantly looping, reading, and retrieving context to make decisions. Every single one of those actions costs compute power and tokens. Tokens are the actual currency of these models, and you pay for every 1,000 you use. You might have heard that token prices are dropping, but that doesn't matter if your total consumption is skyrocketing. The breakdown is pretty clear. Token consumption makes up about 70% of what it costs to run a persistent agent. You aren't paying for the model itself, but for the provider to process those tokens. At current rates, a background agent can easily burn through 30 to 40 million tokens in a single day. That isn't an exaggeration, it is what we see in real-world deployments. The reason the token count explodes is something called the token multiplier. Every time an agent loops to think about its next step, it has to reread everything. It rereads the task, the prior decisions, and all the info it already found. Each loop processes that context again. If a task takes dozens of loops, the agent reads the same data dozens of times. 1 kilobyte of context can turn into 30 kilobytes of paid tokens just because of those repeated reads. The second cost driver is the infrastructure. Persistent agents cannot run on shared temporary compute. You need a place to store the session state, keep audit logs, and sync memory across different devices. That means you are paying for databases and storage systems that never scale down to zero. You pay for them whether the agent is working or just waiting. When you scale up to thousands of sessions, those infrastructure costs become a massive burden. The third driver is observability. You cannot let these agents run in the dark. You have to log every decision, every tool call, and every error they make. If something breaks, you need to know exactly why it happened. But logging at that level creates a mountain of data that you have to store and index. It has to be searchable for compliance, and that infrastructure adds another layer to the bill. The fourth cost is the human element. Someone has to watch these systems and debug them when they fail. You have to tune the prompts and update the policies as the business changes. You aren't actually cutting headcount here. You are just shifting people from doing the work to managing the machines that do the work, and you are still paying for those hours. And here is the problem. None of this is optional. You can't just cut out the logging or the storage to save a few bucks. You cannot run a persistent agent without persistent infrastructure. These aren't extra features. They are the requirements for the system to function. So how do you actually survive this cost curve? The answer is model routing. The idea is simple. Not every decision needs a massive frontier model like GPT-4. Routine work, like sorting data or simple text changes, can be handled by much smaller, cheaper models. You route the easy stuff to the cheap models and save the expensive ones for the high-stakes reasoning. Organizations that use smart model routing end up paying 40 to 85% less than those using one model for everything. This isn't just a small tweak. It is the only way to make the system sustainable. But model routing doesn't just happen on its own. An agent won't figure this out for you. It requires you to make specific architectural choices from the start. You have to decide which tasks go where and build the logic to handle those shifts in real time. You have to monitor it to make sure the cheap models are actually doing a good job. This is why managing cost is now a core part of the architecture. You can't build the agent now and worry about the bill later. The cost has to shape how you build it from day one. Model routing as an economic necessity. In most companies, the deployment of agents follows a predictable, expensive pattern. They pick a top-tier model like GPT-4 or Claude and tell every agent to use it for every single task. It doesn't matter if it's complex reasoning or just simple data entry. Everything goes to the same place because it's easy to set up, and the big models are good at everything. This approach is an economic disaster. The assumption behind it is fundamentally flawed. Not every task is equally hard, and they don't all need the same level of brainpower. When you send everything to a frontier model, you are essentially hiring a world-class consultant to answer your emails and schedule your calendar. You are using maximum power for minimum complexity, and you are burning money every second. The model that actually works is very straightforward. You identify what the agents need to do and find the cheapest model that can do it well. Simple classification goes to a small model. Basic data extraction goes to a cheap alternative. You only use the frontier models for the complex, novel problems where that extra power actually matters. It sounds obvious, but it requires work that most organizations are skipping. First, you need a way to sort the work as it comes in. The agent has to look at a task and decide where to send it before it even starts. This requires a dedicated routing layer. Some people use a small classifier model for this, while others use specific rules. The method doesn't matter as much as the fact that the decision is intentional. Second, you have to test those decisions. If you send a task to a smaller model, is the quality still there? You need clear metrics to compare that output to what the expensive model would have done. You have to find the breaking point where the cheap model starts to fail so you know where the limit is. Third, you need explicit routing policies. This is the governance part that people often miss. These policies aren't just technical, they reflect your business risks. You might decide that anything customer-facing always goes to the best model because an error there is too expensive. Meanwhile, internal reports can use the cheaper options. These policies are not permanent. They have to change as your needs change, which means they need constant oversight. You have to monitor if they are being followed and if they are actually hitting your budget targets. The big problem is that most agent frameworks don't treat routing as a priority. It's usually an afterthought. If you try to bolt it on later, you end up with a messy, custom solution that doesn't work across all your agents. One agent follows one rule, and another does something else. The inconsistency starts to spread. This is why you have to build cost management into the foundation. It isn't an optimization you do after the system is running. The cost defines how the entire system should be structured. The companies that get this right gain a massive advantage. They don't just save money. They gain the ability to scale because their math actually works. The companies that don't figure this out eventually hit a wall. The costs become too high to justify, and the agents that looked great in a pilot become a massive liability in production. The question isn't whether you will eventually need to route your models. The question is whether you will plan for it now, or wait until the bill is already too high to pay. The governance layer, Agent 365 explained. We've spent the last several sections building the technical case for persistent, multi-device agents with sophisticated cost management. Now we hit a wall that technology alone cannot solve. You can build the most elegant agent architecture imaginable, you can implement persistent sessions, you can route models intelligently, you can coordinate multiple specialized agents across your organization, and then you realize You have no idea what your agents are actually doing. This is where most organizations discover they've been building without guardrails. Agent 365 is Microsoft's response to this discovery. It's positioned as a control plane for AI agents. Not an enhancement to Copilot, not an add-on feature, but a foundational layer that treats agents as first-class workforce participants, governed with the same rigor you'd apply to human employees. Let's be precise about what that means operationally. Most organizations today have agents scattered across their environment with zero visibility. An agent in Salesforce. An agent in Jira. An agent built by the finance team in Azure. An agent created by marketing in Power Automate. An agent someone's side project deployed last month. Nobody has an inventory. Nobody knows what permissions each agent holds. Nobody understands what data each one can access. This is the shadow AI problem. Autonomous systems operating in your infrastructure without any central awareness. Agent 365 starts by forcing visibility. It maintains a central registry of agents. Not just the approved ones you know about, not just the ones that have gone through procurement, all of them. It discovers agents running in Microsoft 365, Azure, Power Platform, and external systems. It catalogs them. It identifies the ones nobody knew existed. This registry becomes the single source of truth for agent inventory across your organization. Then it applies governance across 5 core pillars. The first pillar is identity. We've discussed intra-agent IDs earlier. Agent 365 makes these mandatory. Every agent gets a distinct identity in your directory, not shared service accounts, not generic integration users, specific identities that belong to that specific agent and no other. This is where the entire governance framework hinges. The second pillar is policy. Once agents have identity, you can apply conditional access policies to them. You can define role-based access control specific to agents. You can say, this agent can read the customer database, but only between 9 a.m. and 5 p.m., and only from our internal network. You can enforce that policy at the authentication layer. You can apply sensitivity label policies that determine which classification levels this agent can access. You can implement DLP rules that prevent agents from exfiltrating data to external systems. Every access control mechanism you've built for humans becomes available for agents. The third pillar is observability. This is where structured logging becomes mandatory. Every agent action gets logged, but not just agent ran in your audit trail. Detailed structured logs that capture which agent acted, what identity initiated it, which data was accessed, which tools were invoked, what decision was made, and what the outcome was. This creates complete traceability. When something goes wrong, you can reconstruct exactly what happened and trace it back through the chain of agents and decisions to find the root cause. The fourth pillar is interoperability. Agent 365 governs not just individual agents, but how agents communicate with each other. When Agent A calls Agent B, you need visibility and policy enforcement on that interaction. Which data flows between them? Is Agent B authorized to act on behalf of Agent A? Should that inter-agent communication trigger additional audit logging? Agent 365 provides the framework for making these decisions explicit. The fifth pillar is security. This means threat detection specifically tuned for agent behavior. Anomalies that might look normal for user activity become red flags in agent context. An agent suddenly accessing data it has never accessed before. An agent making more API calls than is typical. An agent attempting to escalate its own permissions. Agent 365 feeds these signals into your existing threat detection infrastructure and surfaces them for investigation. What this collectively creates is governance at agent scale. You're not managing 1 or 2 agents carefully. You're governing hundreds or thousands. You're applying consistent policy across all of them. You're maintaining visibility into what they're doing. You're enforcing compliance requirements. You're detecting when something goes wrong. The reality is that most organizations are still in the discovery phase of this. They've deployed agents. They haven't inventoried them. They don't understand what permissions they hold. They have no idea whether policies are being enforced. This is the gap that needs to close before agents can safely scale. Agent 365 is the framework for closing it. The interoperability shift. We've been talking about individual agents as though they operate in isolation, but the real power emerges when agents stop being standalone systems and become nodes in a larger network. The problem is that most organizations built their initial agents without any framework for them to communicate with each other. Agent A lives in one system. Agent B lives in another. They operate independently. If you need them to work together, you have to wire them up manually. You build custom integration logic, you define ad hoc data passing mechanisms, you create one-off coordination rules that don't apply anywhere else. It's like returning to the days before we had APIs, when every integration required custom code written specifically for that pair of systems. This doesn't scale, and it prevents the kinds of workflows that actually drive business value. The future is agent-to-agent interoperability, not as a nice-to-have feature, as a structural requirement. Here's what that means concretely. Agents can call other agents, not through chat, not by pretending to be users and triggering them through a UI. Through structured APIs. Agent A encounters a problem it can't solve alone, so it invokes Agent B programmatically. It passes along relevant context. Agent B executes. Agent B returns results. Agent A incorporates those results into its ongoing work. The entire exchange is auditable. The data flows are traceable. The permissions are enforced. This enables workflows that are currently impossible. A customer support agent encounters a request it can't resolve without inventory data. Instead of escalating to a human who manually checks the inventory system, the support agent directly calls the inventory agent. The inventory agent checks stock, returns availability, and the support agent completes the resolution without human intervention. The customer gets a faster answer, the support staff is free to handle genuinely complex issues. The workflow is end-to-end automated, but this creates an architectural requirement that most organizations haven't addressed yet. Agents need a standard way to communicate. Right now, if you want Agent A to call Agent B, you have to know B's API. You have to understand its parameters. You have to know what format it expects responses in. You have to handle its error conditions. You have to know whether it requires authentication and what kind. If you build another agent C and you want A to call C as well, you have to learn C's API separately. Every agent uses different conventions, different parameter formats, different error handling patterns. You're building integrations, not orchestration. The answer is standardization. Microsoft is moving toward Model Context Protocol, MCP, as the lingua franca for agent-to-agent communication. MCP provides a standard contract that all agents implement. When Agent A wants to call Agent B, it doesn't need to know B's implementation details. It knows B implements MCP. It knows how to structure an MCP request. It knows what format the response will be in. It can invoke B with the same logic it would use to invoke C or D or any other MCP-compliant agent. This sounds technical, but the implication is organizational. Once agents communicate through standard protocols, agent networks become composable. You can build new agents that orchestrate existing ones without custom integration work. You can mix agents from different vendors, different teams, different organizations. The barrier to building complex workflows drops dramatically. But this introduces a governance complexity we haven't fully confronted yet. When Agent A calls Agent B, what happens if B is compromised? What if B has been poisoned with malicious instructions? What if the data flowing from A to B should be restricted? What if policy says A isn't allowed to trust B with certain classes of information? Agent 365's policy layer has to extend beyond individual agents to inter-agent communication. You need to be able to define policies that govern which agents can call which other agents. You need to enforce data classification policies at the boundaries between agents. You need audit trails that capture the entire chain of agent interactions, not just individual agent actions. You need to make permission decisions real-time based on the context of the inter-agent call. This is the governance frontier. It's where organizations that have figured out individual agent control are about to discover the next layer of complexity. But it's also the opportunity. Organizations that master agent interoperability, that build the governance frameworks to make it safe, will unlock automation at scales their competitors can't reach. Data protection in a multi-agent world. The moment agents start calling other agents, data protection becomes exponentially harder. Think about the flow. Agent A retrieves a sensitive file from SharePoint. It's classified as confidential. The agent needs that data to make a decision, but it isn't equipped for the next phase of work. So it hands off to Agent B. It passes along the relevant context. Now Agent B has access to that confidential information. Agent B completes its part and calls Agent C, forwarding everything it learned. By the time we get to Agent C, the data is 3 steps removed from where it started. It's still the same sensitive content, but now it's propagated across 3 different systems with 3 different permission boundaries. This is where traditional data loss prevention completely fails. DLP systems were built for a different era. They work at the application boundary. You configure them to stop sensitive data from leaving your email, or to block financial records from moving outside the finance app. These rules make sense when people are the primary actors. A user tries to email a file. The DLP system checks it, and it blocks or approves the action in seconds. But agents don't operate in seconds. They operate at machine speed, and they operate across boundaries that DLP systems were never designed to monitor. When Agent A calls Agent B with sensitive content, that isn't a user action. It's not traffic crossing a perimeter that a traditional gateway can inspect. It's an internal API call. It happens at microsecond latency. It might be one of thousands of calls happening simultaneously across your network. You can't inspect each one in real time with old tools. By the time you've analyzed the data flowing from A to B, it has already moved to C and D. The problem goes deeper than speed. It's about the architectural assumption. DLP systems assume they are the enforcement point. They sit at the edge and decide to allow or block. But with agents calling agents, there is no single boundary. The data flows through a network. The enforcement points aren't gateways. They are distributed across every single agent that touches the information. Sensitivity labels make this even more complex. A file in SharePoint is labeled confidential. That label stays with the file when Agent A grabs it. But when Agent A passes context to Agent B, does the label travel with that context? Does Agent B inherit the restriction? Usually, the metadata is silently dropped during the handoff. Without explicit design, you lose the connection between the data and its classification. The data moves, but the governance disappears. The solution requires a shift in thinking. We have to stop treating DLP as an external enforcement tool and start treating it as a design constraint. Policy-driven agent design means agents are built with data boundaries baked in. You don't deploy an agent and hope your security tools catch a violation. You configure the agent to respect boundaries before it ever acts. Agent B knows it's restricted from handling financial data, so it's programmed to refuse any request that involves it. Agent C knows customer workflows need extra approval, so it's hard-coded to escalate rather than acting on its own. This requires a real policy architecture. For every class of work, you define the data it can touch, the changes it can make, and who it can talk to. These aren't rules enforced after the fact. They are constraints embedded in the configuration. The agent knows its permissions at runtime. When it hits data outside its scope, it doesn't try to process it and hope for the best. It refuses to proceed. The operational reality right now is stark. Most organizations have policies designed for users. They have no framework for agent boundaries. Their labels don't extend to handoffs. Their taxonomies don't account for how agents transform data. This gap gets wider as your network grows. It isn't a technical glitch to fix later. It's a foundational requirement that has to be solved before agents scale. The security paradox: persistence creates risk. There's a brutal tension in everything we've discussed. The features that make agents useful are the exact same features that make them dangerous. Persistent agents are more capable than ones that disappear after a task. That's the value. But capability, when it's uncontrolled, is just another word for risk. Let's be direct about the threat. A persistent agent with memory can be poisoned at a distance. An attacker doesn't need to breach your servers. They don't need to compromise the execution environment. They don't even need to sit at a keyboard running code. They just need to put malicious content somewhere the agent will eventually read it. It could be a document you share with a teammate. It could be an email in an inbox the agent monitors. It could even be a web page the agent visits during a search. The attacker hides instructions in that content. They look innocent. They might be buried in the formatting or disguised as metadata. The agent processes the document, summarizes it, and stores what it learned in its long-term memory. The attack is now living inside your infrastructure, waiting. Weeks later, the agent is working on a totally different task. It pulls up that poisoned memory for context. The hidden instructions resurface. The agent acts. It moves money. It deletes files. It escalates its own permissions or sends data outside the company. The connection between the action and the original poison is so far apart in time that you might never trace it back. That is poison that lives in time. Cross-device access creates a different kind of mess. When an agent's state syncs across devices, a compromise on one device compromises them all. You might have a phone that is less secure than your laptop. Maybe it's a personal device, maybe it belongs to a contractor. An attacker gets into that phone, steals a session token, and now they have access to the agent running on your corporate core. Compromise once, poison everywhere. The attack surface expands because every agent is a path for lateral movement. In traditional setups, movement follows network paths. An attacker hits one server and tries to pivot to the next, but agents are different. They are designed to call other agents. They are built to pass context between systems. They hold long-lived credentials. If an attacker compromises one agent, they can invoke others on the network and pass along poisoned context. They move through the agent fabric itself. This is the moment defenders realize their old models don't work. You built your security around protecting applications. You put firewalls at the perimeter. You monitored the traffic. All of that becomes partially irrelevant when the threat is moving through authenticated, agent-to-agent communication inside your own network. Privilege escalation becomes disturbingly easy. An agent with high permissions, like financial authority or identity admin, can be tricked into acting outside its scope. A prompt injection in a simple document, a subtle instruction that overrides a safeguard. The agent tries to delegate authority it shouldn't have. By the time you see it, the damage is done. The theoretical defense is clear. You need zero trust for agents. Never assume an action is safe just because it's an agent doing it. Verify every request. Audit every step. Monitor for any behavior that drifts from the baseline. You have to flag it when an agent suddenly touches data it has never seen before, or when a read-only agent suddenly tries to write. But this creates a massive operational burden. Zero trust for humans is already hard. Extending it to thousands of agents, each taking thousands of actions a day, creates a monitoring problem that traditional security teams can't handle. The standard approaches fail here. You can't manually review every action. You can't have a human approve every handoff. You can't build static policies for every possible threat. Continuous monitoring isn't a nice to have anymore. It's the core requirement. You need behavioral analytics that actually understand what normal looks like for each agent. You need automated responses that can isolate an agent the moment it acts weird, without waiting for a human to check a dashboard. This is the reality security teams are starting to face. The persistence and cross-device power that makes agents valuable makes them exponentially harder to defend. The paradox is unresolvable. You can't make agents useful without making them dangerous. You can only make the danger visible and build systems that can react when things go wrong. Isolation modes, sandboxing as a control. We've been circling the same conclusion throughout this entire section. You cannot detect every attack against a persistent agent. You cannot monitor every action at scale. You cannot build static policies for every threat. And the truth is, you shouldn't try. The shift in thinking that changes everything is simple. Stop trying to catch the attack. Instead, prevent the damage from happening regardless of the threat. This is where sandboxing comes in. It's an area where the GitHub Copilot SDK represents a structural advancement that most organizations haven't absorbed yet. They introduced something called OS-managed sandboxing. This isn't a software layer where one vulnerability undermines the whole system. This is the operating system itself constraining what an agent can do at the kernel level before it ever has a chance to break the rules. In a real-world scenario, you tell the OS exactly what the agent is allowed to touch. You tell it the agent can read from these specific directories but never write to them, and it can make network calls to these domains but nowhere else. You block it from spawning subprocesses or accessing raw device files. These aren't suggestions or policy guidelines that a compromised agent might ignore. These are hard restrictions enforced by the kernel that the agent physically cannot violate no matter what instructions it gets from a prompt injection. The benefit here is deep. If an agent is poisoned or tricked into executing malicious instructions, the sandbox stops it from breaking out and causing damage. An attacker might embed instructions to copy sensitive files to an external server, but when the agent tries to make that network call, the sandbox blocks it. Full stop. The agent can't find a workaround because the restriction lives at the OS level, and that isn't something it can circumvent with clever behavior. This is a philosophical shift in agent security. Instead of trying to prevent a compromise, which is nearly impossible at scale, we contain the damage when it happens. We assume the breach is coming and design the system so a breached agent can't move through the network. But there is a cost. Sandboxing adds latency because every system call goes through extra validation. Network calls have to be checked against allo lists, and every file operation gets intercepted and verified. For an agent doing thousands of operations, that overhead adds up quickly. You might see a 20% drop in performance, which is fine for some tasks, but a deal breaker for time-sensitive work. This is why the emerging pattern isn't to sandbox everything. It's to sandbox intelligently. When you trust the source of the input, like an agent processing work from your own internal systems, you use direct execution. The agent runs with full access to its resources, so it stays fast and efficient without any sandbox overhead. You're making the bet that your own systems won't poison the agent, but when the agent processes untrusted input, like documents from external partners or user-submitted content, you run it in sandbox mode. You take the hit on latency to gain the protection you need. Even if malicious content tries to take over, the sandbox prevents data exfiltration. From a governance angle, this becomes a compliance control you enforce through policy. You don't just recommend sandboxing for high-risk agents. You require it. You create mandates stating that any agent touching customer data, financial systems, or PII must run in isolation. The reality is that most organizations aren't ready for this yet. They don't have the infrastructure to manage OS-level isolation at scale or the monitoring to verify that sandboxing is actually active. They haven't thought through the complexity or the performance trade-offs. But this is the frontier for the most security-conscious teams. Not detection, not prevention, containment. And the tools to do containment at scale are finally becoming available. The multi-tenant scaling problem. Building an agent for one user is straightforward. You know their context, you know their permissions, you design for their specific needs. Everything is simpler when the scope is limited to a single person. But everything changes the moment that agent needs to serve 10,000 users at the same time. This isn't a linear scaling problem, it's a categorical shift in how you build systems. This is where most organizations fail quietly. They build a proof of concept that works beautifully, then they discover fundamental flaws the second they try to deploy it to production. The core challenge is isolation. When multiple users access the same agent, you cannot allow one person's context to bleed into another's. You cannot let sensitive data from one session end up in a different one. You cannot allow permissions granted to one user to accidentally apply to someone else. It sounds obvious, but implementing this at scale is where the complexity gets hard. Think about what multi-tenancy actually requires. Each user needs their own session to hold their specific context, including the task they're working on and the data retrieved for them. That session cannot be shared or reused. It must stay isolated from every other session. But you can't spin up a new database or a new virtual machine for every single user. You need thousands of sessions running on the same infrastructure, multiplexed across shared resources, without letting their contexts collide. The architectural answer is external session storage. The agent runtime stays stateless and doesn't hold any session information itself. When a request comes in, the runtime pulls that user's session from a central store like a database or a cache layer. The request executes with that specific context, and when it finishes, the session is written back to the store. The next request from that user pulls the session again, while a different user gets a completely different context. The runtime doesn't have to remember anything between requests. This looks clean on a whiteboard, but in practice, it creates new ways for the system to break. The real challenge is synchronization. If you have 10,000 users triggering requests, you're writing 10,000 session updates every second back to your central store. You can't solve that with better indexing. It's an architecture problem. You need replication and consistency guarantees to handle the load. You need conflict resolution for when two requests from the same user hit different servers at the same time. You have to ensure that if a server crashes mid-session, you don't lose the work or corrupt the user's context. The governance requirements grow just as fast. In a single-tenant system, you might just log when an agent touches a resource. In a multi-tenant system, you have to log everything. You need to know which user triggered the action, which session it ran in, and which permissions were active. The audit trail for one single action now has multiple layers of context that all have to be tracked and connected. The failure mode is brutal. One configuration mistake or one small bug in your isolation logic can make one user's data visible to another. You might not even find it until months later during a compliance audit. By then, the exposure has been constant, and the actual scope of the breach is impossible to pin down. This is where most organizations actually fail. They build a single-tenant agent and prove the concept works. Then they try to retrofit multi-tenancy onto an architecture that was never meant for it. They bolt on session management and add isolation layers, patching the system until it holds together through sheer complexity. The organizations that actually succeed are the ones that design for multi-tenancy from day one. They assume they'll need to serve thousands of users. They build that assumption into every single decision they make. The observability requirement. You're moving from a single user agent to a system serving thousands. And this is the shift, where visibility becomes the difference between control and chaos. Because in reality, you cannot govern what you cannot see. In traditional systems, visibility is the default. A user logs in, you log the event, they open a page, you record the view. They download a file, it shows up in the audit trail. The system creates a natural record because humans move slowly. Every interaction is a discrete event. You can see the history because the pace is inherently auditable. Agents break this assumption. An agent doesn't navigate a UI. It calls APIs directly. It executes hundreds of operations per second. It processes data. It makes decisions. It coordinates with other agents, all at machine speed. If you try to capture visibility like you do for humans, you'll fail. You'll generate gigabytes of logs per agent every single day. Your alerting systems will fire thousands of times a minute. You'll be overwhelmed by the noise. The requirement is different now. You need structured logging with context baked in. It's not enough to log that an agent used a tool. You need to know why. What decision led to that call? What specific data informed that decision? Which user triggered the workflow? Which tenant is it running in? You need the outcome. Did it succeed? If it failed, why? All of that context has to live in a single entry, because later when you're investigating, you have to reconstruct the chain of reasoning. This isn't traditional transaction logging, it's causal logging. You aren't just recording a sequence of events, you're capturing the narrative of a decision as it unfolds. Why did agent A escalate to agent B? What data triggered that move? Did the response confirm the agent's assumptions? The model changes when you add compliance. Regulators now expect audit trails for autonomous systems. If an agent makes a decision affecting a customer or a financial record, they want proof. They want to see the reasoning. They want to see the data. They want evidence that your policies were actually enforced. This isn't a nice-to-have feature. It's a hard requirement for regulated industries. Your logs are now a compliance artifact. But here's the problem. Most logging infrastructure was built for people, not machines. You have logs for file modifications. You have logs for logins. You have logs for user errors. None of that is designed for an agent generating 100,000 entries a day. None of it handles intricate causal relationships that you need to query later. When something goes wrong, when an output is wrong, when a security issue pops up, observability is your only window. You have to be able to ask, which agent took the action? What was it thinking? What had it seen? Without that visibility, you're operating blind. You can't understand failures. You can't improve behavior. You can't even tell when something has subtly drifted. This is the foundation. It comes before governance policies. It comes before isolation. It comes before cost. Observability. The ability to see inside the infrastructure with enough detail to prove why things happened. And most organizations haven't built this yet. The governance gap, what's actually missing. There's a massive difference between having a capability and having a framework. Microsoft shipped Agent 365. You can deploy it today. You can create IDs. You can set policies. The infrastructure exists. But that isn't the same thing as actually governing. If you walk into most companies using Agent 365, you'll see the same thing. Agents running in production with no documented purpose. Agents using service accounts shared by 5 different teams. You'll find agents built for projects that ended 6 months ago. They're still running. They're still holding permissions. They're still burning resources. There's no clear owner. Nobody is accountable for what they do. They make business decisions with no human approval gate and no way to say stop. This is the governance gap. It's not a technology problem, it's a framework problem. The missing piece is process. Deliberate processes that treat agents like members of the workforce. Look at the identity problem. We talk about intra-agent IDs as the foundation. But in reality, agents are still using shared service accounts, finance has an account, procurement shares credentials. Operations has one technical user that 5 agents use to log in. Nobody can tell who did what. They're all hiding behind the same mask. You look at the audit trail and see a transfer made by the finance account. Which agent did it? Which human started the chain? Which policy should have stopped it? You don't know. The trail is opaque. Moving to dedicated IDs requires work that has nothing to do with code. You have to change how teams provision agents. You have to ban shared accounts. You have to update deployment so every agent gets its own identity automatically. That's process work, and most organizations haven't done it. Then there's context. Every agent in production needs a documented reason to exist. What process does it enable? Who is the human owner? When was it deployed? What is the business justification for its permissions? This should be obvious. But it isn't. Most agents start as experiments. Someone has an idea and builds a test. The test works, so the agent moves to production. But the documentation never catches up. There's no central record of why the agent matters. This makes governance impossible. When you audit permissions, you don't know if they're right because you don't know the goal. When you respond to an incident, you don't know which agents to check. The approval problem makes this worse. High-risk actions need a human checkpoint. An agent trying to move $100,000, an agent deleting customer records, an agent emailing on behalf of the company. These aren't routine, these are moments where judgment matters. But most systems have no approval workflow. The agent decides, the agent executes. By the time you see it, the work is done. Finally, there's retirement. Agents accumulate. Projects end and processes change. But the agents keep running. They hold permissions and stay open as attack vectors. Nobody decommissions them because nobody is tracking them. There's no inventory, there's no ownership, there's no off switch. The solution is a framework that mirrors how you manage people. Agents need onboarding, they need a documented purpose and a human owner. They need minimal permissions from day one. They need compliance checks. You have to audit their activity and verify their access. You have to watch for behavior that drifts. And they need offboarding. When the job is done, you revoke the permissions. You archive the data. You remove them from the system. That's what governance actually means. It's not the tool, it's the process. The persistent agent as a new identity type. We need to step back for a moment. Most organizations are only just starting to grasp what is actually happening here. This entire conversation about governance, observability, and oversight, it isn't really about managing tools better. It's about something much deeper. Agents are no longer tools. They are identities. This isn't just a change in how we talk, it's a change in how we build. When you treat an agent like a tool, like Slack or Salesforce, you manage it as a capability. You turn it on, you configure it, you delete it when you're done. The organization stays the same because tools just extend what humans can already do. They don't change the nature of the workforce. But when an agent becomes an identity, everything shifts. It gets its own credentials in your directory. It has its own permissions and its own audit trail. It has a life cycle. At that point, it becomes a participant in your workforce. It isn't just helping a human anymore, it is executing work on its own. It makes decisions, consumes resources, and holds authority. This changes everything about your organizational structure. Think about your human workers. They have identities in Active Directory and specific roles they fill. They have responsibilities and they are held accountable for the work they produce. You manage them through HR systems, track how long they've been there, and offboard them when they leave. Now look at your agent workers. They will have identities in Entra and specific permission scopes instead of job titles. Their responsibilities are written into code instead of job descriptions. Accountability is baked into an audit trail instead of a performance review. You will manage them through governance systems rather than HR. But the parallel is unmistakable. This creates a massive management challenge. Large companies are used to managing thousands of people through a clear hierarchy. There is a command structure where everyone knows who reports to whom and how approvals work. Agent workers do not fit that model. An agent doesn't have a manager. Its authority comes from its configuration and its duties come from its design rather than an assignment. You might have thousands of these agents running at the same time. Some are specialized, some coordinate with others, and some only trigger when a specific event happens. They aren't organized around people, they are organized around workflows. So how do you actually keep control? How do you maintain visibility over thousands of autonomous workers moving at machine speed? The answer is that you don't manage them like humans. You govern them. Agent 365 provides the infrastructure, but the actual policy has to come from your leadership. The people who understand your risks and your processes have to decide how agents are created and when a human needs to step in. This makes the question of accountability very difficult. When an agent makes a mistake, who is actually responsible? Is it the person who built it, the team that deployed it, or the business owner who signed off on the workflow? In theory, it's everyone. In practice, You need a clear ownership model where every agent has a human owner. That person is responsible for monitoring the agent and pulling the plug if things go wrong. This future isn't years away. It is happening right now. The most advanced organizations are already managing more agent identities than human ones. They spend more time governing agent behavior than they do managing human performance. Their structures are changing to reflect this. They have teams dedicated to agent security and others focused on how agents talk to each other. Within 5 years, this will be the standard. Most organizations will have more autonomous workers than human workers. We are only just beginning to understand what that means for our culture and our operations. The Build 2026 inflection point. Microsoft Build 2026 wasn't the moment agents were invented. They've been around for years, but it was the moment the industry decided that agents are no longer a bet on the future. They are infrastructure. We saw this through product convergence. Copilot Studio moved to multi-agent orchestration, and M365 Copilot started using the same runtime as GitHub Copilot. Azure AI Foundry began treating agent patterns as primary features. These weren't just random updates, these were different products realizing they needed the same engine and aligning around it. When every product line moves in the same direction, it means a standard has been set. It is no longer negotiable. This convergence changed the rules for developers. The GitHub Copilot SDK stopped being just one way to build agents and became the only way that matters. Other frameworks still exist, but they are now just integrations for this core system. Standardization is what allows things to scale. When everyone uses the same SDK, you can build an agent once and deploy it across VS Code, GitHub, and Azure. Organizations stop paying the tax of managing 5 different ways to do the same thing. The governance signal was just as clear. Agent 365 moved from a preview to being generally available. Microsoft didn't pitch it as an optional tool for compliance. They positioned it as the central nervous system for everything your agents do. The pricing and the marketing all sent one message. You will manage your agents here, not eventually. Now. Companies that hadn't even thought about governance suddenly had a product telling them exactly how it works. But the market signal was the loudest of all. Gartner projected that 40% of enterprise apps will have agents by the end of 2026. That isn't just for startups or tech giants. That is the mainstream. It means having agents is now the baseline for any software company that wants to compete. If your app doesn't have these capabilities by the end of the year, you are already falling behind. These signals create an urgency that most people haven't felt yet. The timeline isn't flexible. If you don't build your agent infrastructure right now, you won't be able to scale when the wave hits. You will be playing catch-up for the next 3 years. This creates a disadvantage that is hard to see until it's too late to fix. A company that started 6 months ago already has systems in the field. They've already learned what breaks and how to fix it. They have the frameworks in place to plug in new features as soon as they are announced. If you are starting today, you have to sprint. You have to cram 18 months of learning into 6. You have to find experts who are already hired elsewhere and retrofit governance onto old systems. By the time you have a system that works at scale, your competitors have already moved to the next level. The reality for most companies is pretty stark. They are still in the phase where they ask if they should even invest in this. Meanwhile, the rest of the market is already asking how to scale it. That isn't just a small delay. It is a capability gap that gets wider every single month. The organizations that get it are moving now, and the ones that don't are about to find out the hard way. From architecture to implementation, understanding why you need persistent agents with governance layers is a start. But it isn't enough. Understanding doesn't build systems, execution does. And execution is where most organizations fail. The shift from "this is what we should do" to "this is what we're actually building" requires a different kind of thinking. The theory says you need 3 layers: a runtime where agents execute, a control plane where they're governed, a set of identity and policy mechanisms that make everything auditable. In practice, building those layers requires sequencing decisions that most architects get wrong. The mistake is starting at the wrong level. Organizations often begin by asking which model they should use or which cloud provider is best. They wonder if they should build custom infrastructure or use a platform. But those are the wrong first questions. They're optimizing for decisions when they should be optimizing for learning. Start instead at the smallest possible scope. 1 agent, 1 workflow, 1 controlled environment, not production. A sandbox where you can experiment without risk. The goal isn't to build something that scales. The goal is to build something that teaches you what actually matters. Pick a workflow that your organization already understands. Not the most complex one. Not the one with the highest business impact. Pick something you can explain in a single sentence. Maybe it's a customer service agent that handles basic inquiry routing. It could be a code review agent that flags common patterns, or an expense report processor that validates receipts. The workflow should be achievable with current technology. The constraints should be obvious. You're building to learn, not to win. In that sandbox, implement the identity layer. Create an Entra agent ID for this agent. Don't use a shared service account. Don't use an administrative identity. Give this agent exactly the permissions it needs to do that one workflow and no more. This is the moment when you discover what least privilege actually means in practice. It's harder than it sounds. Your agent will need access you didn't anticipate, and it'll hit permission boundaries you didn't know existed. You'll need to iterate on what you granted. This is valuable because this is how you learn what governance actually requires operationally. Implement the session layer next. Use the SDK you've chosen and configure session persistence. Make the agent resumable. Test the recovery path. Close the browser, restart the machine, verify the agent can recover its state. This is where you discover whether your session storage is working correctly. You'll see if your backup and recovery mechanisms are adequate and if your data synchronization is actually synchronizing. Only after those two layers are working do you add orchestration. Can your agent call another system? Does it have the identity to authenticate? Can it pass the response? What happens when the system it's calling is down? These aren't theoretical questions. They're operational realities that will break your system in production if you don't understand them now in the sandbox. Then comes governance, instrument logging, configure audit trails, set up dashboards that let you see what your agent is doing. Run it for a week, generate thousands of events. Try to reconstruct what happened during that week from the logs alone. You'll discover gaps. You'll find events that aren't logged. You'll discover that your audit trail doesn't tell the story you need it to tell. Fix those gaps now, in the sandbox, not after you've deployed. Only when those 4 layers are working in isolation do you think about combining them. And only when you've combined them in a single controlled environment do you begin planning the next iteration. The scaling reality is this. You won't scale a system that wasn't designed for scale. You won't retrofit governance onto systems built without it. You won't add multi-tenancy to single-tenant architectures without significant rework. The organizations that scale agents successfully are the ones that designed for scale from day one, but only implemented scale incrementally. This means your first production agent is not going to look like your 10th. Your 10th won't look like your 100th. You're learning at each stage. You're discovering patterns that work. You're discarding patterns that don't. You're building organizational knowledge about what agent architectures actually require in your environment. The timeline is measured in quarters, not months. First quarter, build one agent with all the layers working. Second quarter, deploy it to production. Third quarter, learn from production and build a second agent that incorporates those lessons. Fourth quarter, begin orchestrating the 2 agents together. This is methodical, this is slow compared to the pace of initial enthusiasm, but it's the pace at which organizations actually build durable systems. The organizations that will dominate agent adoption are not the ones that move fastest. They're the ones that move deliberately, learn deeply, and compound knowledge systematically. The competitive advantage of getting this right. The organizations that master agent architecture will unlock automation capabilities that competitors operating within traditional models simply cannot match. This isn't about having agents. Every organization will have agents eventually. It's about what you can do with them when you've built the fabric correctly. The productivity gains that come from coordinated, persistent agents are not marginal. Teams that have deployed agents across interconnected workflows report task completion times that are fundamentally different from what traditional approaches achieve. These aren't isolated point solutions. They are integrated systems where agents hand off to each other, maintain shared context, and operate under unified governance. The data shows 55% faster task completion when workflows are properly orchestrated. That's not a 10% improvement. That's not incremental optimization. That's a structural change in what your teams can accomplish in a given time period. But raw speed isn't the deeper advantage. It's what speed enables. When your teams complete tasks faster, they handle more volume without hiring more people. They move from being consumed by execution to being capable of strategy. A financial analyst team that previously spent 80% of their time on routine reconciliation and reporting now spends 80% on analysis and forecasting. An operations team that was drowning in incident triage now focuses on system design and prevention. The work becomes qualitatively different because the routine work is gone. This compounds across your organization. The cost advantage runs parallel. We've discussed the economics of intelligent model routing and efficient orchestration. Proper infrastructure design can reduce AI spending by 40 to 85% compared to organizations that are over-provisioning or building inefficiently. But the competitive implication cuts deeper than a cost reduction. It means you can afford to be ambitious with agents in ways your competitors cannot. You can experiment. You can deploy specialized agents for tasks that barely make economic sense at higher cost. You can explore workflows that others consider too expensive. And when you find the ones that work, you've discovered automation opportunities that your cost-conscious competitors never knew existed. The governance advantage is subtle but powerful. Organizations that build strong governance frameworks from the start can scale their agent deployment without the security incidents that plague less disciplined organizations. They treat agents as identities, maintain audit trails, and enforce policies systematically. This is not a linear advantage. This is exponential. Each security incident in a competing organization costs them weeks of incident response, audit recovery, and system remediation. Each incident erodes confidence in their agent systems. It slows their deployment. It makes stakeholders nervous about expanding agent authority. Organizations with strong governance don't face those friction points. They move faster because they move safely. The data advantage operates differently. Persistent agent memory, when properly governed, creates organizational knowledge that your competitors don't have. You know which prompts work reliably and which ones fail. You know which agent combinations handle complex workflows well and which ones create bottlenecks. You know which data patterns trigger which behaviors. This knowledge is embedded in your agent configurations. It compounds over time. Your agents become better because they're learning from systemic patterns across your entire organization, not just from individual interactions. Competitors starting from scratch don't have this accumulated intelligence. The talent advantage might be the most valuable. When agents handle routine work like data entry, basic decisions, and routine communications, your human workforce is freed to focus on problems that actually require judgment, creativity, and contextual understanding. This transforms your organization's relationship with talent. You're not hiring people to do repetitive work anymore. You're hiring people to think, to make decisions, to interact with customers in complex situations. The work becomes more interesting. Your ability to retain talented people improves. Your ability to attract better talent improves. You're competing on meaningful work, not on compensation for tedious tasks. All of this compounds into a single strategic implication. Agent architecture is becoming a core competitive differentiator, not a feature, not an optimization. A fundamental capability that separates organizations that can scale and adapt from those that are constrained by manual processes and human limitations. The organizations that have built this fabric correctly are building moats that will be difficult for slower competitors to cross. They have real identity, real persistence, real governance, and real orchestration, and that is the shift. The risks of getting it wrong. Failure in agent architecture happens quietly. You don't wake up one morning and declare a total collapse. You wake up and realize you're trapped. You're stuck inside a level of complexity that you can no longer manage. This is the result of building without architecture. What typically happens is you end up with dozens of isolated agents that cannot coordinate with each other. Finance has one. Operations built another. Customer service created 3 more. Each one works in its own silo to solve a narrow problem. But the gaps between those silos grow wider every month. A workflow that should be automated end-to-end now requires 3 manual handoffs. It breaks because the agents that could solve the problem cannot communicate. Humans become the integration points again. The automation you invested in becomes invisible because the real work, the stitching together of agent outputs, still requires a person to step in. Then the cost spiral starts to accelerate. You deploy these agents expecting to reduce expenses. Instead, you're running hundreds of queries across disconnected instances. You're maintaining separate configurations for agents that should be sharing the same logic. Your infrastructure is optimized for single agents, but you're running multi-agent workloads. Token consumption multiplies because each agent rereads context independently instead of sharing it. Your compute bill climbs. Your infrastructure team asks for budget increases you can't justify. The value isn't materializing, and leadership is starting to notice. The security risk is not hypothetical. An ungoverned agent is a lateral movement vector. It's running with permissions you can't audit, holding memory you can't inspect, and invoking tools without any approval workflows. An attacker compromises that agent because it has broad permissions. It touches systems that should have been off limits. The compromise propagates through your network. And because you have no observability, you don't discover the breach until weeks later when a routine audit turns up anomalies you can't explain. Compliance violations accumulate in the shadows. Your DLP policies don't account for agent behavior. Your audit requirements still assume humans are the only actors. Your data retention policies were written before you had agents holding persistent memory. An auditor walks through your infrastructure and discovers violations you didn't even know existed. The systems you thought were compliant are now generating major findings. Fixing this requires architectural changes you never planned for. Data leaks from places you didn't anticipate. An agent with access to sensitive info gets compromised and exfiltrates data to an external system. But that's not the full exposure. That agent also calls other agents. It passed sensitive data to those downstream agents before you detected the threat. Those agents cached that data in memory. That memory was synchronized across multiple devices. Now the exposure spans your entire system. The scope of the breach is almost impossible to quantify because you have no visibility into where that data moved. Finally, there is organizational debt. Technical debt in agent architecture is different from a messy database. You can re-architect a database. You can refactor a monolithic app. But an agent fabric built without structure is much harder to fix. When agents are scattered across business units with different governance frameworks, where identity is inconsistent and policies conflict, you need organizational alignment to fix it. You have to get business leaders to agree on new standards. You have to retire agents that people have already come to depend on. You end up rebuilding systems from the ground up while trying to keep the lights on. The recovery timeline is measured in years. The cost is measured in constant friction across the entire company. These failures are not theoretical. This is exactly where organizations are headed when they build agents without thinking about architecture. It's the path you follow when you optimize for speed over structure. Conclusion: the fabric, not the chat. The shift from chat to fabric is not incremental, it's structural. Organizations that understand this are building persistent multi-device systems with unified governance. Those that don't are just building expensive chatbots that will fail the moment they try to scale. The GitHub Copilot SDK provided the technical blueprint. Agent 365 provided the governance model. The rest is just execution, identity, persistence, orchestration, control. The question isn't whether agents are coming, they're already here. The question is whether you'll be ready. If this changed how you think about agents, follow me, Mirko Peters, on LinkedIn. I want to hear how you're building agent fabric in your organization. And if you want more of this, leave a review. It helps more people find it.